Okay, hi guys. So as you can see, this is our lecture two. We're gonna learn about computer architecture, and let's make this quick because it's just some theories you have to understand, which will be very important to our further studies. Okay, so what is computer architecture? In this lecture, we'll cover the layers of the computer, the programming language types and the applications, like these kind of like hardware stuff, which will be useful later on. And then okay, so first of all, oh wait, that's the second half of the lecture. Anyways, first we'll learn about computers. So like computers goes from hardware to software. So like the most basic ones are hardware, which is like the circuits and gates. I actually have some knowledge about like logic gates and like designing circuits and like making microprocessors. I can talk for like hours about logic gates. And then above that we have microcode, which is like used to what you do to control these like very primitive circuits and gates. And above that you have like the instruction set, which is purely gives instructions like addition, and even there's no multiplication, right? There's only addition and then loops addition, which is multiplication. And then above that you have the system software, which is OS. So OS gives they creates instructions on the hardware and then like does all the stuff, right? So like the OS will put like instructions into a CPU and let it do stuff. And above that we have the low level languages, which is above the operating system, right? We have C and we have basic, we have like assembly, which is like very old stuff, but we're dealing with C, right? So as you can see, like C, why is C so important? Because it deals with the OS directly. It's talking directly to the computer, right? And above that, we have like C++ and Java. I mean, like C++ is not that high level, but because it adds like a whole bunch of annoying features, just put it there with Java. And C is honestly just better. And above that, you have the user level, which is like applications. So for example, use Java to write like a program that's like with a user interface, and then the user will interact with that. But actually, Java will use this C to compile, and then C will like put the thing into the executable file to the OS, and the OS will run it. So like when you write Java stuff, it's actually like need a C translator, right? Okay, so what is a computer hardware like? So what is it inside that makes our program runs, makes your browser like search stuff? Well, so the computer has a CPU, it has a memory, and has arithmetic logic unit. Well, nowadays it's mostly like inside the CPU as well, so this is kind of old. So basically, like the CPU just takes an input and then like do operations in the memory and then gives an output. For example, like I input two numbers like one and one, and then it puts one and one in the memory, and then it does addition through the ALU, and then outputs two. So it like puts one in the memory, puts another one in the memory, and then adds them together, which is two. You take the two out of the memory and output it. So that's the most basic stuff. Okay, so we're talking about input and outputs, right? And like the CPU is basically like the brain of the computer, right? Right here, it connects to a whole bunch of different stuff. So there's two so-called bridges on the CPU. One is the north one, one's the south one. So that's very smart. There's no like east and west bridge. So on the north, you see you can have like CPU, video cards like GPU, and RAM is like memory. And on the south, you have like these kind of like input and output stuff like keyboards, disks, BIOS, which is what you run when you start the computer. So as you can see, like north bridge is where you put all the fast stuff, right? CPU has to be very fast. Well, actually, it should be like CPU should be the center, right? Because South Bridge actually goes into North Bridge, and then North Bridge goes into CPU. So I don't like the way this thing is drawn because CPU should be in the middle, honestly. And then memory should be very fast, right? Goes to a North Bridge, it goes directly to a CPU, and then GPU as well, right? And then internet connection. Well, now we have Wi-Fi. So this diagram is not the best. I mean, in my opinion, you should put like CPU in the middle, and then you have North Bridge on there, and then you have like South Bridge on North Bridge, and then you have all bunch of like I/O on the south one, and then like RAM, GPU, those kind of stuff on the north, and then north goes into CPU. So this is not like the most accurate representation, but whatever. Okay, so memory hierarchy, like I said, memory is like where you store stuff, right? So how does it work? Like CPU have to take stuff out of memory and then like put it back into memory. So memory gotta be really fast. Like I'm pretty sure when you play like video games, like what do kids even play nowadays? Like okay, let's say when you play Roblox, right? Like your computer is like rendering all this like crap on the screen and it has to like make like 60 frames per second, right? So how does that actually work? Well, so like inside the memory is like it stores different stuff. Like memory gotta be one of the most important things you'll deal with and see, and you have to be very careful with it. So for now, you don't have to like know it's you don't have to learn so much about memory, but I'll just put it here. So the CPU has like tiny memory spaces inside, but we call them like registers. And then there's also three level of caches, but now just imagine them as one. So like cache is like also a memory, but it's like very small. And then like you have the main memory, and then you have like the storage. So as you can see, like the bigger these things are, the slower they are, right? So the registers are tiny, like they store like what 16 bytes, but they're very close to the CPU, so they're insanely fast. Well, you have like the main RAM, which is like pretty big, like a few gigabytes, right? But it's big and it's far from the CPU, so it's like slower. Well, the cache is something in between. So like you put something that like you use very frequently, but it's not that big, so you can like get it very quickly when you need to use it. And there's even like three levels, right? From the quickest to the slowest, from the big to small. So yeah, that's how like computers like very optimized to do the stuff we do. So that's why you can like play Battlefield 5 without like lagging, right? Oh, another example is like for example let's say like you play Roblox, like you play this one game on Roblox like 20 times a day, right? So that's likely that the game will put it in the cache. So like you can get the game assets very quickly. You can load the assets very quickly when you play. And then like the inventory or those kind of stuff like you access every like 5 seconds, they might put it in the register. It's just an example. In real life, that's not how it works, but just so you get the idea, right? So you use the inventory more frequently than you like load game assets and those kind of stuff. So it can be loaded very fast when you need it. Okay, so here's a better definition. So computer memory stores information such as data and programs for immediate use in the computer, right? Well, that's kind of like BS. So here's my analogy. So okay, imagine the storage as like the backpack. I don't know why I wrote pack page. I don't even know what I'm doing. So imagine storage is like backpack where you carry to school. You have like math books, physics books, whatever in there, and your pocket is like the memory. So like you can reach into your pocket and like get stuff. For example, your phone or like octopus because you use those very often, but it's very small, right? So you can only put like limited items in there, but you can get it very fast. Well, storage is like a backpack. You can put tons of stuff like your lunch, your water bottle, whatever. But to get it, you have to like put your bag on the front, sling it over, and like zip it open and do whatever the like stuff you want. So it's like bigger but slower. And then pocket is easy for you to reach frequently, right? And then so things you take out of the pocket is like the memory, and then you take out of the memory, and the things you take out of the backpack is like the stuff you take from the storage. Yeah. So why is memory important? Like I said before, it's just because like memory is like basically memory is storage, but it's like incredibly fast, and you lose it when you shut down your computer. So yeah, you can just imagine, but memory is not storage. Okay, memory is not storage. It's just something else, but you get the idea. So when you run a program, for example, our hello world last time, right? So that thing is when you execute it, it loads into the memory and it runs. So you have to remember when you write programs, like memory is finite. Like my computer only have like what 8 GB, right? So if you like write a program like that loads like a 4K video and then you're rendering like 120 frames per second, that's likely not gonna be enough. So you can't fill all those stuff into the memory, right? So that's why the computer lags. Actually, it's not the exact reason why, but it's something to do with swaps and like storage. I'll tell you about that later. So yeah, memory is your greatest restraint and resource. It's like in product design, you have to like have a restraint. So when you write your program, you also have to keep in mind how much memory you have. If you want to go competitive programming, like they're only gonna give you like a few K, like 256K to do a task. So memory is very precious. Back in my days, we only have what, like a few megabytes of memories. Yeah, that's the olden times. don't know why there's a duplicate slide, right? Is there? No, it's not. Okay, yeah, so what happens when you run the program? So what happens when we execute hello.c? So let's find hello.c. Okay, right, still remember this, right? Oh, it's not hello.c anymore, it doesn't matter. So what happens when you run it? Like, what happens when I gcc, this thing? Okay, so and then when I run this, so what actually happens is like it takes the hello.c from storage and copies it into memory. Okay, too long, don't read. Just pause the video and read it by yourself. Yeah. Okay, you're done. Okay, so now chapter 2.1. So memory and computer architecture. This is more about programming related, so you won't get really bored. Okay, allocating memory. So when you like make a variable in the code, it's actually a piece of memory physically on your RAM. So for example, right, when I have int a, like what is int a? Int a equals 5, but what is int a? Like int a, right, is a variable with 8 bytes. So what it is actually is that when I write this thing and when I run it, like the MMU is gonna take like 8 bytes, like 8 physical bytes on the memory, and then it's gonna write electricity into those wires, right? And it's gonna write 5 in binary into those wires. So int a, the moment you run it in the code, it's gonna create like a space in the memory that's like physical, right? That memory is int a. So this thing is not just some like random code. It's a real thing. Int b as well, float as well. There are real things inside the memory. So I can physically like open the computer, use my hand to like take those bytes that represent int a out of the memory, and guess what? Int a is gonna like stop existing because I took it out of the memory, that physical space. It's not possible, but I can. Just saying. So yeah, as you can see here. So address is so cool. Like how I said, like int a is like placed inside the memory, right? So well, guess what? Each byte in the memory has an address of its own, right? Of its own. So int a, perhaps let's say have address like it starts from 0 and goes to that. So depending on how big your memory is, right? So int a could be something in hexadecimal like 0x, just to represent hex, and then some random number after that. So yeah, some cool trivia to know. Okay, so yeah, we're gonna learn about pointers now. I know I'm going really fast, but you guys are really smart, so it doesn't matter. Okay, so pointers are the most important concept in C. Basically, this is how it works, right? Use the star to represent the pointer. So int star pointer is you know what? Screw this image. Okay, so int a is a variable. Int a has the address of 1. Okay, int star b is a pointer, right? It has the address of this thing. So pointer is also a variable, right? So I can write like okay, I'll just make it null, doesn't matter. Okay, so this is also a variable. Like this is an int star type variable, like also 8 bytes. I can physically open the memory and like find this thing, right? So a has an address, this has an address, right? Address are like it shows where your memory is in the memory. So I can write like a equals 1 to add 1 into here. I can write int star b equals the address of a, and store the address of a into b. So I can literally like write this. Okay, boom. Now I'm storing the address of this thing, into the address of this thing. So like this is an address that points to a memory, and inside that memory stores another address. Okay, when I first learned it, it's a bit confusing as well, but it all makes sense when you write it for yourself. So it also works for chars, characters. That's how we make strings, you know. So if I write this, hello world, it means that now the value of char star a is the address of the constant hello world, right? So hello world is actually a string, as you can see. Has the address of 0x01, and char a has the address 0xff, hypothetically. So inside the memory, like this thing would be h, and this thing would be e, and this thing, so like 1, 2, 3 would be h, e, l, and etc. And the last one, d, would be 0a, which is the 11th. So actually, like when I write char star a equals hello world, the value stored in 0xff is equal to 0x01. So like I put an address into a memory. So the variable stores an address. That's a pointer. So yeah, just read this yourself and you'll get it. Okay, so now we're talking about malloc. We're moving super fast because you guys are super awesome. So malloc. Malloc is actually a memory allocation, but because programmers are lazy, so we just say malloc. So you use malloc to allocate memory, right? So for example, let's say let's do the string example. Okay, char s. Let's just call it s equals okay, so I essentially made a character string that's like 1024 in length, or you can say it's a 1D array. So this is equivalent to writing it's equivalent to this. Okay, same thing. Because I first malloc the size of char character, so 1 unit times this thing, and I convert the type to char star, which is a pointer, was equivalent to a string of 1024. Okay, as you can see here. So memory leak. Okay, memory leak. Remember when I said MMU like allocates pieces of memory to your code? Like you're essentially borrowing memory from the computer. So what happens if you don't return them? Well, it gets lost, right? So you don't want that to happen. So you have to free S. So if you keep borrowing and you don't return, like the memory's gonna get effed up, right? I'm telling you, it's gonna messed up. So you gotta like return the stuff you borrow, just like in real life, right? So you don't want your computer to like get like fragmented into like a mess. Okay, great. So now let's do some advanced memory stuff. Okay, I'll do let's just annotate this code because we don't like it anymore, like that. Oh yeah, let's do some cool stuff which is 2D array. Okay, let's do an easy one. Okay, let's call it A. So let's make it equal to yeah, let's make 2D array of 10 first, because to be simple. Let me think. How do you write 2D arrays again? Yeah, you know, honestly, I forgot. But let's give it a shot. Okay, it's 10, right? Okay. So you double press Y to copy, and then you press P to paste. And then I can do 2YY to copy twice and paste. And then paste again. And then paste again. Okay, so I have 10 lines, right? So this thing should work, if I remember correctly. So let's print it out. Remember, this is a nested loop. So you have one variable inside another, right? And the existence of I exists only between these two parentheses. So just beware, you cannot use the variables of the same name or else it's not gonna work. So let's just print f, and then it's a one variable, right? So let's character, and then a, these indexes, like 2D arrays, like a matrix. So the I, let's just make it the y-axis, because this is actually the y-axis. This is the, oh crap, I'm giving you the answer to the homework. Oh, what? Damn it. Okay, whatever. You're gonna encounter a problem in homework, but I essentially just gave you the answer because I'm too nice. Okay, so yeah, this code should just work. It's gonna print, oh, yeah, maybe I forgot something. The thing is, like, after you write too much like other programming languages, you get bad habits. Yeah, god damn it, I actually forgot how to write C. You know what, maybe I should search online. Nah, I'll use my memory. Memory serves. Yeah, what's the error method? Oh, haha, haha. Yeah, ignore this. God damn it. This is what happens when you write too much high level trashy programming languages. But as you can see, our 2D array worked perfectly, flawlessly, right? I made a 2D array and I printed it out using 2 nested loops. That's how 2D arrays work. Now I'm gonna demonstrate how to do it in a malloc fashion. So I'm gonna allocate memory. Okay, so let's do char double pointer. So as you can see, you can stack pointers, right? That's so cool. So let's just convert. Okay, and then okay, we essentially did the same thing here, and you know what? It might just work. So let's just do 12yy to copy 12 lines and then paste it here. Just delete these crap and then do that. I bet there's gonna be a weird bug, but yeah, there is. Oh yeah, I just forgot to include a library. Let's see. So you have to include apparently probably this thing, standard library.h. Pretty much every code needs it. Yeah, okay. Yeah, apparently you can't write it this way. You know what? We'll just do another way. So let's just do it simpler first or more complicated. Depends on you. So we're gonna turn a 1D array into 2D. So this is how we're gonna do it. Okay, 1D array. So we're just gonna make a equals to we can't even do that. Okay, let's use a loop to show we're highly intelligent. Okay, we're gonna fill this thing with this. How about the same stuff we did? Oh, you know what? Let's just make it yeah, you know what? Let's just make it singular thing. Let's just make it K, cause Kevin. Okay, K for Kevin. Maybe like that. Oh yeah. Also, it's a character, so let's do that. Okay, so now we're gonna do a big brain move. So as you can see, like each row is 10, right? So we're gonna represent it goes from 0 to 100 and it's all K. So we're gonna do the 2D index using one thing. So like for example, 1 is like the first row first element, but 11 is the second row first element. So we're just gonna do I times 10 plus j. So that's gonna be like every time y goes up by 1, it goes to the next row, and every time j increases by 1, it goes to the next column. Yeah, makes sense. Now this should work. As you can see, the code worked flawlessly, printed out an array of k's, but we can do it. We can make it better, right? So let's do it. Actually give value to it. What variable? Yeah, you know what? Let's just do this. We're gonna do some ASCII level hacking. Yeah, this should be fun. I hope it works. Yeah, it did. Okay, so we essentially like ASCII table, you learn it later on, but as you can see, like we have created this interesting pattern in a 2D array. It was a 1D array, but we made it appear 2D. So it's a very good way to do it. Yeah, so now you learned about advanced memory. If you still don't get it, just ask me on Discord. Okay, now look at these example codes. If you still don't understand, these example codes are very good. So it shows you how the thing works. Okay, just pause the video on each slide and look at it yourself, okay? Okay, demo 2, this is to demonstrate how compiler uses pointers. Okay, it doesn't matter. Okay, pointers like actually very Chad, right? For square root. Okay, next. Allocation, it's a malloc again. Okay, dynamically allocate, we just did that. Okay, now it's homework time. Wow. Okay, this is super easy. I think I forgot to teach you something, so you still need that for homework, so let me just teach you right now. Okay, so we talked about addresses just now, right? So int a, let's just make it 0. Okay, print f. So let's print out the address, right? We use p for address, and then we use the address symbol to get the address. So let's just print out the address of a, and let's see what it is. Wow, it's that. Okay, so now you can see that's the address of a. So now we're gonna do that. B equals the address of a. Okay, so now we can print f. Let's print the address of b, and then let's also print the content of b, because b is a pointer, so what it stores is also 1. Okay, so look at it very carefully. Here we're printing the address of b, and here we're printing the address that is stored in b. Okay, as you can see, like the address of b is different from the address of a, but the address stored in b is the address of a. So that's why when I change b, I can change a. So let's just say, okay, let's just do that. Okay, so a is originally 0, but I changed a by changing the address that is stored in b into 2. So now a should be 2. Right? You see it's 2. Wow. So that's why it's so useful. You can use one variable to represent another variable, okay? Now you know the address. You can do this homework question. So pause it and do it. Okay, now question 2. Pause it and just read it. Okay, great. Now question 3. Pause it and read it. This is very difficult, and if you did it, film a video and show it to me. I'll give you extra credits for it. Okay, great. That's a long lecture, 30 minutes, eh? Actually, I feel like I still missed some stuff about pointers and addresses. It's really important. Pointers, the single most important thing in C. So if you don't understand, you like literally just scan this code and like use this URL and join the Discord server and DM me to get help, because I want you to learn this thing properly, because it's really just that important. Okay, well, good night, guys. Enjoy and have fun doing C. Okay, bye.